Once we know how to solve triangles, then we can introduce two new notions that are widely used. They're very applicable. There are many certain circumstances where these come into play. Angle of elevation and angle of depression. Now, let us suppose that we have a vertical cliff and the desert floor. Let us suppose up here we have the coyote. Let's suppose down here we have the roadrunner. And let's suppose down here we have the food, the bowl of food. All right? Let's assume this is a right angle. Now, the coyote is above the roadrunner. The coyote looks downward to see the roadrunner. However, the roadrunner is below the coyote. The roadrunner looks up to see the coyote. In this circumstance, we have both angle of elevation, angle of depression in play. Now, here is the big deal. The big deal of the day is this. Angle of elevation and angle of depression are, wait for it, they are always measured against the horizontal. Angle of elevation, angle of depression, always measured against the horizontal, never the vertical. They're always measured against the horizontal. Here's what that means. Draw a line between the coyote and the roadrunner. The roadrunner has an angle of elevation. Think of elevation as I'm looking upward. Angle of elevation is looking upward. And so here's the angle of elevation, right? The angle of elevation is always measured against the horizontal. So from the perspective of the roadrunner has an angle of elevation. This is the angle of elevation. The coyote has an angle of depression. Angle of depression. Depression means you're looking down, right? You're depressing, you're looking down, right? However, this angle is not. This is not the angle of depression because the angle of depression is never measured against the vertical. The angle of depression, you need to supply an extra line in the figure. The angle of depression is here. This is the angle of depression. This is the angle of elevation. Measured against the horizontal, measured against the horizontal. And here's another key element. In the same picture, if one person is above looking down, another person or cartoon character is down looking up, in the same given picture, the angle of depression and the angle of elevation are alternate interior angles. These are parallel lines. These are alternate interior angles. In a given figure, the angle of depression equals the angle of elevation. The coyote's angle of depression equals the roadrunner's angle of elevation. All right? Another key notion is this. Very often, this will occur. Very often, this circumstance will arise. If you know it, it's not that hard to handle. You just label it and go right along your merry little way. If you're not aware of this, it's a sure place to make a mistake. Suppose we are given, call this angle F. So it's a vertical cliff, 90 degrees. 90. Suppose the cliff, suppose little r, is given to be, let's just pick a number out of the sky. It's 150. And let's make it seem real. It's 150 feet. So for one time, I actually will use units. 150 foot high cliff. All right? And let's suppose we're given the coyote angle of depression is, let's say it is, and we can pick a number out of the blue sky. Let's suppose it's 22 degrees. Suppose the Coyote's angle of depression is 22 degrees. And let us find the distance between the Roadrunner and the food. Find the distance between the Roadrunner and the food. Let's just call that X. That's what we're looking for. We're given R. R is given to be 150. You don't need to be given that. Just one of them needs to be given. You don't need to be looking for that. Just one of them needs to be desired. So I'm just picking numbers out of the blue sky. This is the 90 degree angle. That's given. But then it says the Coyote's angle of depression is 22 degrees. And the key is, as I have it drawn here, and this is a place where many students fall off the beam. If you get this correctly at the start, you're going to be gliding through this like no trouble. If you mess this up at the beginning, it's going to bother you for a good long while. The key is, as the picture is currently drawn, 22 degrees, the angle of depression is not in the picture. As is currently drawn, the angle of depression is not in the picture. You need to supply this little segment so that now you do know this angle is 22 degrees. And then you have an option. You need to put something inside we need to have interior angles of the triangle. You have your choice. It doesn't matter which one you pick, but pick one of them and go with them. The simplest version is this. Well, simple is whichever one you understand or see first, I suppose. But one simple version is this. The Coyote's angle of depression is equal to the Roadrunner's angle of elevation. If this is 22, that means this is 22. And now we do have an angle. We have a given side. We have a desired side. And we're back to the previous lesson. Or, if you don't like doing that, we know these two angles are complementary. So if this is 22 degrees, this must be 68 degrees because they must add up to 90. And then we have angle, we have desired side, we have given side, and we're back to the previous video lesson. So the key is, very often the angle of depression might not be in the triangle you're working with. You need to translate that given information into something else you can work with. All right? So let's do this. Let's suppose we know this is 22, therefore this is 22. Now we're going to solve the problem. All right, so let's, I'm going to move this given information here. So we're given R is equal to 150. We said that was 150. So what do? We take the given angle, right? From the perspective of the given angle, you look at what is given and what is desired. What is given, what is desired. The given is opposite, the desired is adjacent. The given is opposite, the desired is adjacent. We could find this hypotenuse, but we've not been asked to, so don't burn time trying to find something you're not asked to find. But we do know that this is opposite, this is adjacent, so we know which one of the trig functions we're dealing with, which of the basic three functions deal with opposite and adjacent. Yeah, tangent is opposite over adjacent. Tangent of theta is opposite over adjacent. Tangent of 22 is 150 over x. And so just say it and write it. Tangent of 22 is equal to opposite 150 over adjacent, which is x. Cross multiply, set them equal and solve. Cross multiply, 150 is equal to, don't know yet, times tangent 22 degrees. Divide both sides by tangent. Divide both sides by tangent 22. So 150 over tangent of 22 degrees is equal to the thing we're looking for. At the very last, don't go too soon, at the very last, go to the calculator. And I need 150 divided by the tangent of 22. And I have 371. Oh, I didn't tell you how many decimals. Let's suppose we want 1 decimal place. All right, let's suppose we want 1 decimal place. So we have 371 point, this says 263. So round it to 1 decimal place. This 6 means we round up to a 3. So for our purposes, x is equal to 371.3, and we actually have units. We might as well go ahead and use them, feet. Make the physics people happy if we actually use the units occasionally. So that is certainly fine. There's no problem with that and no issues there. Now, what I'm going to do for the rest of this video is solve this using a different method, just to show that it doesn't matter which one you pick. See, what we could have done is this. Instead of saying this is 22, therefore this is 22, we could have said this is 22, therefore this is 68 degrees. And if that's 68 degrees, we should be able to solve from the perspective of 68, we have opposite over adjacent. If we had done that, again, 1 decimal place, if we had done that, we would say tangent of 68 is equal to opposite, which is what we desire, over adjacent, which is the 150, cross multiply, set them equal, and solve. Cross multiply x is equal to cross multiply 150 times tangent of 68 degrees. And let's go to the calculator. So this is 150 times tangent of 68 degrees. And, I'm sorry, I hit the wrong button. 150 times tangent of 68 degrees. I have 371.263, yada, 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 round to 1 decimal place. So we're going to round that to 3. So we would use x is equal to 371.3. We have them, we might as well use them. This is feet. And notice, it doesn't matter which version you pick. It doesn't matter which version you pick. So whichever one you happen to see, whichever one you happen to use, that is fine. There's no problem. Just go ahead and work the issues that you have, work the problem the way you see it. And as long as it's a valid procedure, it doesn't matter which one of those 2 methods you pick, you should get the same answer either way.